All right, so next up we're going to do some more examples showing how to do a hypothesis test for proportions. And on your test, you're generally going to have kind of these baby steps, these intermediate steps that you need to answer. I'm not going to just throw you in and say, do the hypothesis test. What's your conclusion? Be sure to show all the supporting steps. I'm going to scaffold it, okay? So in this example, we have a marketing research company reported that 65%, hold on, of online searches in March of 2010 used Google as the search engine. Okay, good, I'm on a highlighter. So that's an important number probably. Our network administrator wants to determine whether the percentage of searches that use Google is different in his company. He samples 400 searches, finds that 295 of them used Google. Can he conclude that the percent of searches that use Google differs from 65%? I'm going to highlight that question in a different color because that's going to inform us for our alternate hypothesis. Okay, so what pieces, so I'm going to write over here, what are the pieces of information that we've been given? Well, we know the sample size, right? He samples 400 students searches. So that is our sample size. Now we want to ask ourselves, hey, is this a proportions problem or is it means? And of course, here we're looking at the percent of searches. So that we could have just as easily said the proportion of searches. So we are definitely doing a hypothesis test for proportions. Right? Anytime you've got a question, can he conclude? Is there evidence of a change? Is it different than what's claimed? Is it higher than what's claimed? Anytime there's like a question like that, it really means we're doing a hypothesis test. Okay, so we've got our sample size. We have a sample proportion, right? We have 295 of the 400 used Google. Now, what claim was made? Well, the company is reporting 65% use Google. So that's going to be our claimed population proportion, which I'm going to write population proportion, which is P, right? 65%. I'm going to write that in decimal. Okay, so right now we have enough to write our null and alternate hypothesis, right? So we can say, hey, our null is that the company is, the proportion of searches that use Google is no different from what the company claims, right? So it is still 65%. So no different than claimed. Sorry, my handwriting's bad. All right, what's the alternate hypothesis? Well, and that's where the sentence comes in that I highlighted in orange, the question. Can he conclude that the percent of searches differs from 65%? So that question, which really was formed before he took the sample, right? Because he said he wants to determine whether the percentage of searches that use Google is different, right? He said, is it different? So that means he doesn't know if it's higher or lower, but he thinks it's different. So that tells us what our alternate hypothesis should be, and that it is a two-tailed test, that he thinks it is different, thinks our population proportion is something different from 65%, is not equal to 65%. Okay, so remember the null is a statement of no difference or no change, right? That the percent of searches that use Google is still the same as what was claimed, at 65%. The network administrator says, I think it's different. I just don't know if it's higher or lower. All right, so we've got our null and we've got our alternate. So not a bad idea to throw a sketch in here. We'll just fit it in right here, all right? So we've hypothesized that the population proportion, the center of our sampling distribution, should be 65%. And 295, let me see here, I'm going to pull up my calculator. 295 over 400, I don't have a good idea of what that is. There we go, it's almost 75%, so it's 0.7375. So somewhere up here, So that's our p hat. This is our p. And this is a two-tailed test or a two-sided test. Okay. This is maybe new, right? So we are going to shade not just our area above in the upper tail, but the same size area on the lower tail. And we're just going to, we don't know exactly how big that is, not yet, but we have that visual on the sketch so that we remember to do it at the end. Okay. So what about our conditions? Is this a random sample? Well, we're pretending that we're the administrator here, the network administrator. We know what we're doing. Even though it doesn't say the word that it's random, we're going to assume, and that should be a fairly safe assumption, because if we're acting in that role, we know what we're doing, right? Mostly. Do we have at least 5 successes and 5 failures? Right? Well, we don't need to calculate this. Well, we do, right? Because when you check your sample size for a hypothesis test versus a confidence interval, you're going to check with NP, not NP hat, right? So we're going to say, hey, 400 times P, which was 0.65, and I can say, that's whatever the heck it is, 400 times 0.65 on my trusty calculator, 260, which is bigger than 5, right? And 400 times Q, remember Q is the complement, right? 1 minus P. In fact, maybe I should write that. So that's 400 times 0.35, right? Which is 140. And are these things all basically independent? It's a success failure. We don't expect our probability to change for each one. So are we good with our conditions? Yeah, we are. All right, well, what do we do next? Well, we need to find that area in the tail. In order to do that, we need to calculate a test statistic. Now, because we know that we're doing proportions, we're going to be doing a z-score calculation, right? So we're going to say, hey, z p hat minus p over square root of pq over n. So this becomes plug and chug, right? My p hat was 295 over 400 minus our population proportion. Our claimed proportion is 0.65, 65%. And then we're going to divide by the square root of p, so 0.65 times q, 0.35, over our sample size, which was 400. And now we're going to go plug that into GeoGebra because I am not a human calculator. Oops. I thought I had GeoGebra up, but apparently not. There we go. Okay. So we said 295 over 400 was our p hat minus our population proportion 0.65 divided by square root of 0.65 times 0.35 over our sample size of 400. So we're getting a pretty big z-score here, relatively speaking. We've got 3.669, let's just say. 3.669. All right. Okay, so what is our P? So that is our test statistic. I'll put that here. This is, because remember, test statistic is a general term. So I'm not telling you if you're running a z-test or a t-test, right? You have to know it's a z-test, a z hypothesis test for proportions, and know what z-score formula to use. All right, so what's our p-value? Well, we can say, hey, the probability that our sample proportion is bigger than 0.65, we can go find that with GeoGebra, right? 3.669 is our z-score. I'm going to go over in GeoGebra to the probability calculator, make sure I'm using the normal distribution, make sure I've got selected right-tailed, right-sided, right? And I'm going to put in that z-score. What was it? 3.669, I think, right? So our p-value 0.00012 think that will work. Pretty darn small, right? 0.00012. But that would be if this is a one-tailed test, right? This would be a right-tailed. But that's not what we have. We have a two-tailed test, so we are going to double that p-value, right? Because this, what we found is that that right tail has that very, very small 0.00012 area. So our probability that basically the absolute value of our p-hat, now we don't even want to say that, I want to say that in terms of z-scores, z greater than 3.669, right? Absolute value. So that's going to be both sides. We're just going to double 2 times 0.00012. So that's easy, 0.00024. There's our p-value. And we're almost done here, right? Almost. We need to do our conclusion. So now, that's a super, super small probability, right? So if the company is still has 65% of their online searches using Google, the probability of getting the sample we did or anything further out in either direction is 0.00024 or 0.024% chance. Super small. What are we going to do with that? That's super unlikely. We're going to say, I don't think that null hypothesis is right. So we're going to reject the null. What does that mean? And we can say, basically you can go back to the sentence, the question, can he conclude that the percent of searches that use Google differs from 65%? Yes. There is strong evidence that the percent of searches that use Google in his company differs from 65% or is not 65%, okay? So we can say there is strong evidence that the percent of searches, and because I'm running out of space, searches that use Google in his company, right, but I'm not going to write that, differs from 65%. So our test did not say, oh, is it higher, is it lower? No, it just decided it's not 65% anymore, and that's where we're at. All right, that's it for this one.